Hello, what's up? I am Jun-chan and welcome to the stream. We are back doing some Haskell and some attempt to try and compile a package called structures from Edrockmet, where he experimented with cache oblivious data structures, which is something that is not even to this day, it seems like frequently used in a functional programming context. Of course, that's also because generally in functional programming contexts, close to the metal performance is not necessarily everyone's concerns, right? But that's something I'm actually not very familiar about, and so I thought that going back to this work would allow me to get started on this and understand it a little bit better. So where are we? Well, what I noted last time is that basically we've been upgrading. We've played quite a bit trying to get a build plan that worked with the different package bounds, and what we didn't find one that worked, and that's probably because Ed used some intermediary versions of packages that were maybe unpublished at the time, or maybe they've been even changed or overwritten. The history of specifically the vector package is a bit strange around that time. So I right now I'm exploring this idea of getting the package, the vector package, to a level where it's, I think, 10.9. Let's take a look. 10.900, I think, 0.10.900, which is one of these sort of hiccups where it seems like a new API shows up but then disappears on 0.10.9.1. Once we get this going, then maybe I'll try and get actually to vector version 0.11, which is where that new API stabilized. And one key aspect of the new API is that instead of having stream, which had a size in them, which is kind of counterintuitive for stream, the new API contains bundles, which are the things that internally use streams, but also provide a size, which I assume in our case is useful for things like fusion and whatnot, which we which I don't understand quite yet, but that's where we're at. So the latest compilation error we got was looks like here, where let's take a look at my note specifically. What it say? Data vector fusion.merge and inserts need to be updated for bundles. Right, so if we take a look at data vector map.fusion and merge, we see indeed that, well, what do we see? First of all, that's not where the errors are occurring. So let's make sure that we're looking at the right error messages and whatnot. Looks like it. So let's look. I think this is all used in data vector.map and in the zip function specifically, I believe. So yeah, 128 is the first error. And apparently we have a type of bundle. Right. We have a type of bundle ID RKKV. But we want a stream ID KV, and we want a stream ID KV because I suppose right, it's the return type. So let's just try and see whether changing the return type here is actually going to work. Can we try JC? Do we even have JC ID? We do not, but it could be made available in the shell. I think if we're doing some compilation, then it kind of makes sense to do that. So let's see, how do we put JCAD in are Nix developed, that should there are stop jobs. Not sure what that means. Does not contain flake.next. Right. Okay. Yeah, but that should be fine because we say nix packages.flake. Okay, how come? Let's add flake.nix, just see if that doesn't mean anything. I think it shouldn't, but well, okay, indeed, same error. So why would this not work here? And well, let's have a check at whether that commit is actually the release 18.09 commit. Okay, I see. Copy. We're doing a little bit of Nix again. Okay, and that's the branch, and the commit is 925 ff36, right? 925 ff36. And so yeah, indeed, that's not going to contain a flake.nix, but it should be fine if we do input nix packages.flake equal false. So why isn't this working? I suppose let's double check where we're using nix packages. We're importing it here, we're inheriting here. Let's also check whether in fact this is related to what I just commented out. No, it's not the case. So we somehow, in the midst of thing, broke our config. Well, I don't have good Git hygiene, so it's all my fault. But this is a little bit strange. Okay, let's comment this out. And okay, this is now a little bit ridiculous. Yes, it does not contain Nix file. Okay, let's search for flake equal false, and this error message. It could be that the flake equal false is only available with a recent version. Seems store path. It's not a flake. Flake schema input.bar flake equal false. You declare to use the same version as the parent Nix packages. Okay, let's just search for the error and see what we get. Pinpoint with flakes. Error. Unknown settings. let's use the actual search here and contain. It does not contain. If it is inside a Git repo, it is forcing the non-dirty behavior. I can reproduce. Dot flake. What does this have to do with anything? Okay, that doesn't have anything to do with our problem. Things like code complex. X file special restrictions. Okay. Let's try and narrow this down, but does not contain. Let's try to show that it checks for the file at a store path where it does not exist. No, but that's not our issue, right? Okay, let's see if something stupid going on. Yeah, no, it does at least have primitive type checking, but we look like we are in a shell, though, is the thing, right? But we don't have GHCID, right? We do not. So yeah, it's a little bit unclear what's going on. But it also might mean that my flake is actually wonky. It could be spitting out an error, but it's actually working. But then why would, well, I suppose I need to actually reactivate it. Oh, okay, well, so is it because it's using a different build profile than Cabal build? No, -W, -01. So it's unclear why it's rebuilding this whole thing. I would have expected that it would be in this new style, but it seems like it invalidated the cache for some reason. I am in fact not using the index pinning. No, I am using the index pinning from fairly recent time. Oh boy, that's not good. We have a bunch of new errors. I built data generics. How strange. Oh, maybe it's not using this new style form of compiling. Could that be the case? Cabal REPL. That's what's executed. Oh well, we can manage with Cabal build, I suppose. This is old tooling, so let's not waste too much time trying to fix it. We've already wasted quite a bit of time. I mean, it's not wasted, it's just exploration, right? Okay, not in class type constructor or class bundle. Yes, because if we wanted to change this to bundle, right, then fusion merge, we need to take bundles. So, and fusion merge right now takes streams, but that's one of the things is I could revert back to having actually the size being passed, and then call this actually bundle. And in that case, I don't even know whether we need to call it stream. Yeah, it's not clear that we do. But I think here we have a bundle. But let's double check the type signature for bundle. MVA. So yeah, that corresponds to having RK here. So that's the V for some reason. Okay, so I think that will mean RK here, and then bundle ID. Well, M, probably we can keep it polymorphic, I suppose. So to stream of the same. But then, yeah, that's the type. I'm thinking about the size right now. Is that going to be the size of like the width in some sense, something like that? Let's remind ourselves what bundles are. The vector is VA and the chunk is VA. With chunk being defined where in the vector library? Because I know that there's chunks defined, well, defined in the map actually. There's some chunks right there, but they're locally defined. So what are chunks? Where are chunks from in the vector library? Could they be from bundle size? They don't look like they are. So maybe from bundle. It doesn't look like it. It does export chunk though. From bundle monadic. Okay, so maybe I missed it. Yeah, I did miss it. Okay, so chunk is chunk VA, and so it is definitely a different type than this. KA and array K, yeah, so definitely different. That's going to be confusing. Such that what? Such that we have some rank 2 type here. Sounds like it's a mutable vector of A in modad M. A mutable is from is mutable from? I think from prim, right? GC primitive. Maybe from control monad primitive? That would make sense, and then prim state would also come from there, I think. Or not. Go to the index. Mutable array. Well, yeah, that's definitely recent version. So, oops, we need to first get back in time to wherever vector the cabal needs it, and that's primitive 0.6. In that case, maybe 6.4. And then it's immutable here, no? And still mutable array. Chunks the constructor. Maybe it's from data vector generic base. Yeah, probably. Yes, it is. Immutable version of the pure vector of type VA with a state token S. Right, so this is a little gymnastic with type classes that I see a lot, but I'm not super familiar with it yet. I mean, especially in this kind of format, actually in the data type. But we were thinking about how we're going to replace bundle ID RKKV in map.fusion here. So bundle M RKKA. Yeah, I mean, I suppose that's what we try. But then type, pattern matching in the bundle is going to be something different. But before we get there, let's also change the type signature here, and that's going to be M. Oh yeah, and it's going to be actually M and RK. So okay, let's try and type check this. Don't mind compilation errors, but let's see whether actually we get a little bit further. Okay, so you don't have access to R, which would be an array. And right, so yeah, maybe we need to be polymorphic in that. But this can't be K, can it? I don't think it can. Okay, maybe we, is there going to be a cycle here? Maybe not. but it feels wrong. Array K, array V. Hey, Counter. I'm good, thank you. I am playing with this structures library from a while back. How about you? How are things with you? Let's see. Maybe I can import that R. Let's try. Don't believe in that so much, but and maybe specifically, I think it's actually a constructor from array. Type constructor class R. Okay, so what is it? Yeah, it's a type constructor of array. And it's not exported. So that's not going to work if it's not exported. So in that case, I think maybe we keep that polymorphic, don't we? Let's double check on what's up in maybe a way that it's used. It's polmva. Do we have any case where we zip, for instance, here? Zip. Good. Hey, nice. Excellent. Yeah, I have been thinking about setting up a Pi hole, you know, for advertising, like a DNS resolver for inside my house, and it probably makes sense to do that with NixOS on the Raspberry Pi. How difficult was it? Zipping MV A MVB. Yeah. So it's just this key value format that might not work out for us. But you know what? Let's say V. Is there a type constraint on V? There isn't. It's completely polymorphic in V. Okay. So then let's go to town and say V. Whoopsie. So that's merge, and let's do the same for insert. Okay. Nextcloud, yeah, that's cool. Yeah, I've installed version 02 of this. I think. Are you going to use? What are you think of using it for? Like file sharing and also maybe serving your documents and things like that. I think these days it has some collaborative editing tools as well, right? Okay, what's up? Data vector map fusion, and you say that there's still some R's somewhere. Well, I would like to disagree. There. Okay, but you don't find the data construct stream. Okay, well, yeah, that's totally fine. So, okay, and then the yield skip, and sure, okay, that's fine. Because that was all in stream monadic, right? Stream monadic and stream. Hold on, where is where's the definition of stream? Here, data stream, blah. Step, yes, and step has yield skip done, exactly. So we know that we're not going to have any of that, so it makes sense that we have all these errors here, because now we're moving forward in time and using bundles instead of streams. So that's something actually that might be better. So I could use from stream and the size to create the bundles, and then I could use the bundle versions, right? Basic setup was straightforward, but it looks like the Nextcloud services are not starting. Hey, well, you use it for my family trying to degoogling yourself. Nice, that's excellent. Nextcloud service is not starting. When are you? You're looking forward to try it out and troubleshoot next weekend, I suppose. Internal stream fusion combinator used to merge streams for addition. Okay, let's refresh our memory about what's going on here. We have right. Merge is the function that does a thunk, which will take the A's and the B's in that weird binary or non-binary counting system and create a thunk for the concatenation of those two chunks. So, but it clearly tries to do this really fast. And so what I can see it's trying to do here is that first it zips the A's and it zips the B's, which transform a chunk of KV into a bundle, or earlier it was a stream of KVs. And then we fusion merge them. So I suppose, yes, I suppose that if we did have still our stream ID KV instead, then stream.zip we might not want to use stream.zip, right? We might want to use bundle.zip. Zipping and zip, yeah, bundle.zip will do the right thing, right? So the question is, do we want to be using bundles already here? Do we want to go from chunks to bundles? For that, we would need to make sure that we can generate a bundle from chunks. Actually, a bundle from arrays with the G with data vector generic. I mean, I think we probably want to do that, right? I feel like we do want to. So let's call this bundle. And in the end, we're not going to use streams here, I don't think. I think we're supposed to make this all work with bundles. Yeah, which is not super easy, but so in this case we do bundle, and here we say probably just, well, not V, but well, we might say V. No, let's call this W. And it should work for all W's. And then, right, so then from generic, can we create a bundle instead of a stream? Because if not, then we are in trouble. Generic. Right, a stream these days actually creates a bundle. But a bundle VA, shouldn't we have, are there non-monadic bundles? I didn't realize that. Let's see. Which bundle are we using here? Data vector fusion bundle with bundle. Am I missing something? Data vector, bundle. Right, so there is a bundle that is not the bundle monadic and that just uses ID. Okay, well, you know what? That's probably better to use than the one we've been using. So let's swap that. Let's just use bundle. And let's call this also bundle. And this is going to be also bundle, I think. And then we don't have to use M. I mean, I suppose we could have tried to keep that. Doesn't really matter. I don't think, especially not for our Tory example. And then we remove M here, and we have V. Okay, so that's one thing. And then in map, we want to do the same thing, and so we will have bundle ID, but that means we don't import bundle from monadic, we import it from bundle. And here as well, which allows us to then use bundle.zip, and g.stream actually creates a bundle. So let's see how that goes. So in my fusion we have a bunch of streams left, so let's deal with those. Oh, so it's the data constructor. Okay, so that's good, I believe. We can now well, actually, yeah, no, if I deconstruct the bundle, I kind of have to go in the bundle ID. And let's just double check that those constructors are exported. Yeah, they are. Okay, so it's well, it is what it is, right? We have to try and make sense of this. So this is going to be a bundle. And we're not gonna have we have SLMs, which is actually a stream. So what's the relationship between SLMs and schunks? Is that the chunks tell us what the V is, whereas the LM don't. So here, do we need to know the size of the chunks? Well, I don't exactly know how this works, so I suppose the answer is I don't know. But what we know is that we can recover a stream simply from the first simply from the first two constructors, I believe. That would be the first constructor SLMs, and then if we skip chunks and vectors, we should get the size. Except we don't want to we can't skip them, because we are going to need to reconstruct a bundle with those things also combined, whatever they are. Okay, so in that case, we'll call this well, we call this chunks for now, and then we call this vector and this is going to be chunks A and vex A, and then we're going to do, and this is going to be sure SA, why not, except that I think size, what is size? Size is size is in size, I bet. Right. An exact int, a max int, or unknown. Oh boy. Okay, but there's a num instance. Okay, so in that case, we're good. We can say this is size A. And then we do, well, we need to start, these are heavy pattern matching lines. Something like that, and then we do stream. Step S f mapped with blah instead of do. Oh. In the stream one, sorry, I'm not following. In the stream one, do you mean like in here? There's no step function here, so I don't think that's what you mean. Stream step A SB chunks B vex B and size B, and that should allow us to do size A plus B thanks to the num instance. Size A plus size B, I believe. And then what? And then we do want to rebuild a step function. So for that, I suppose we do construct a stream with step, and then with this with merge start as well. So that should be fine. Except here we want some combined chunks and some combined vectors, whatever that means. So let's just see whether actually this is already getting us somewhere or not. Is this the right syntax for type holes in Haskell? Don't even know if there was type holes in 710. Parser on input where? Yeah, I need to close this. Not in scope data constructor bundle. Yeah, that's not the right one because we're pattern matching now on the monadic bundle. Okay, so vector.fusion.bundle.monadic, and we get bundle constructor from there. And then type holes are, we're not in pure script, so it's not question marks. And okay, bundle.bundle. Yeah, there we probably don't even need that. Okay, and we'll need the stream constructor too, actually, because we have the stream stuff in there as well. Okay, and am I stream monadic, and so I need to import to output step as well. And that would be here, step. So at least you should know about the constructors, and you do. But then, because second argument of bundle, right? Okay, fine. So that's because 35. Yeah, we need to. This is actually really M bundle, but I suppose it's fine. And we need to do the same thing here. Okay. And we need to import ID. Is that from functor? I don't know. Bundle. Should just be from prelude. Don't we import prelude here? We don't. Okay. Import prelude ID, and not just the type, I believe. It doesn't export it. It must be re-exported from one of these guys then. Maybe, well, actually, yeah, no, I'm not sure. Okay, Google shall help us. Well, indeed, data vector fusion util. Oh, I've been thinking that it's been ID as identity, the identity functor, but it's not. Identity functor is identity. This is in fact from data vector fusion util. So what's in there? Data vector fusion util. What's ID? ID is just identity. Okay, so it just comes from a time where maybe this wasn't in the prelude or whatever. Okay, so no big deal. We import it, specifically ID. Okay, now we have stuff. We found a hole, and so it means that things kind of make sense, except that stream should have 2 arguments, but I've been given 3. Yeah. That's right. Hold on, is that right? 90. So yeah, okay, that's where it's at. And to do this, we're going to need to split things again. But let's focus on the first implementation, although maybe the second is going to be easier. Let's do the second instead. Okay, so bundle the stream, stream, and then chunks and vex, and then n size a, and then we create a bundle which will have the stream with the step and the searching thing. And then, well, in that case, probably just the chunks and the vex. Except for some reason you wanted to have 2 max +1 because we insert the thing. So now we have size a +1, and I think that should actually just work. And indeed it does. Okay. Okay, well, let's see whether in the bundle monadic we have stuff that helps us understand. Maybe there's even a merged thing here, to be honest. No. Monoid instance, maybe? No. well, let's take a closer look. So chunk's going to just extract the chunks. So, okay, if I understand this correctly, it might be, we will see whether the implementations match up to this interpretation. But basically, what I'm thinking this is that, well, it's a stream with some sizes, but it's also a kind of a structured stream such that you can actually extract each element pointwise, or you can export them in chunks in a vector of size v. Each chunk having a vector, having a size of vector v. And then is that the remainder? Because not everything will fit in the chunk, so maybe you have a remainder VA. That sounds plausible to me. Sounds totally plausible. So let's see whether that's the case. How could we find out? Well, generate cons. Oh, all right. Well, there is a concatenation. Hold on 1 second. There's a concatenation. And the concatenation just ignores the vector there. It just puts nothing in it. So is that a bit like a stateful thing? Like as long as you haven't started to get chunks, then you can't know whether you have a vector left. Okay, let's see. Actually, how does it work from a stream? Well, it also uses nothing when it constructs it. So I think that means that we know what our merge is going to be. So let's just write our merge. But also makes me wonder whether actually this isn't just concat. Use too much streams for addition. So there's quite a bit of stuff in case the streams don't have the same size. I suppose the thing is that the bundle is still going to have the same chunk size. It's just going to have double the elements and the size. Yeah, so hold on. Is it the case maybe that we just need this concatenator and we're done? We're done if the concatenator for monadic stream is actually something that looks a little bit like this. Then we win, I think. Plus plus. There we go. And yeah. I can be convinced that this is right. Although, what are these constructors left? And is there an either somewhere that I haven't seen? Either? There's no either. Why are we getting some left and rights? Is that part of the? It's not part of the step. So why are we getting left and right? I am not clear at all about what this is. Oh, okay, I see. Right, got it. Yeah, so it must be the same. Basically, the left-right thing comes from the fact that the step function here is passed, or let's say the new stream is passed a value of type left SA. So of rather type either SA. And it's going to be an either SA is B because we have right as B, and that's going to be inferred by the type checker. And so now we can have we've constructed the new stream, and then when we'll iterate on the new stream, each time we get an S, well, the S we'll pass the SA to step A and get the step from there, then decide on returning that's a bit strange, really. I would think that this is AB and stream M either AB, but like look at it's not, so it means because it's the same type anyway, so for some reason then the end stream, the result stream, how does the result stream keep type A? Okay, because that's the S is actually just a sort of an internal implementation detail. What matters is what the step SA returns, and the A there is the value. So it's what done, for instance, going to return or skip. The trouble though is that it looks like no, yeah, it looks like it's correct because it's going to return like some S, but the A type is this or this. So okay, the S is used for synchronization, internal synchronization. In this case, it's going to alternate between SA and SB, and that's really it. That's the way that those are concatenated. They're actually interleaved, right? No, they're not. They're not interleaved. It's going to stay left SA until it's yielded or skipped all of the stuff and it's done, and then it will do the SB. So the logic is not interleaving. it's actually doing all of SA and then all of SB. So it is indeed a concatenation. Okay, and so now we have to look at this really hard to read code and see whether that was doing the same thing. So let's look at the original code because I've mangled it a bit. Data vector map fusion. Okay. So we take our step A and our step B, and we do a merge start. And merge start is what? Our merge start is, yeah, it's just the equivalent of the left, I suppose, right? But it takes both SA0 and SB0. And so in the first step, we get a merge start. And then it's only executing step A, and it's merging, I mean, it's whatever this data type, oh yeah, that's merge state, that's the data type. And that's a cancellative addition, apparently. Because we have a map, and so concatenation is maybe not going to be enough. So either and maybe that's why we won't be able to use yeah, I suppose the semantics of the map needs to be something else. But let's look at the call side here. So first zipping the keys and the V's, and then doing the merge. And the merge is supposed to give us a chunk KA, which should be twice the size of each of these chunks. And is there anything else to it? I don't think there is, really, because the whole balancing of that non-binary system is done outside of the chunks, but those are just chunks. Those are just chunks, but no, those are just chunks. So it means we should end with an array of keys double the size and an array of A double the sizes. Are the keys, do they need to be in any particular order here? I don't think so, right? I might need to refresh my memory with this this construction. Well, insert should be sufficient, actually. So insert is such that, right, the first we have this data.map containers package nursery, and then when we over that, then we insert the A's. Right, otherwise we empty the nursery, and then we create a chunk with the list from the keys and the list from the values. And we insert XS0 into it. Hold on, no. We want to insert K0 and V0 into the X's. Okay, well, whatever. Inserts right. Insert just insert takes chunks of keys and chunks of values, and they're initialized with the nursery stuff, M0. And so, and insert also takes the x as 0, which at the beginning is going to be empty, I suppose. So the A's and the M, so if the list of keys, oh right, no, I'm misreading the parentheses. It's a chunk of, that's the chunkies of arrays and keys right there. So A's is already a chunk of arrays and keys. So if XS0 is M0, meaning the empty looker color, then we just put A's inside M1. So that's the singleton color. And however, if we already have B's in an M1 RXS0, then we put the A's and the B's, and we also have a thunk for merging the A's and the B's. And then now we link back to an empty color. And then if we counted now more than 2, and that we try to insert in something that has already 2 things in it, then we actually put the A's and B's, and we just add the A's and we keep the B's and C's and the thunk unevaluated still at this point. We allow ourselves to delay the evaluation of the thunk. And then if we insert another A's, but this time into the M3, then we now carry. And so how do we do that? We force the thunk, and then we go to 2, but now with the A's and B's, so the unevaluated B's and the A, we don't need to have those former things because they are being evaluated in the CDs, in the thunk. And so we create an M2 with the A's and the B's, a new thunk, and then we recurse by inserting the evaluation of the thunk into the remainder. Okay, so that makes sense. That does refresh my memory. And so clearly, yes, well, yeah, no, clearly, yes, this will grow each time. The merging will grow. And clearly, order-wise, doesn't matter. That has nothing to do with order. Which I suppose is a little bit confusing, because lookup definitely used the ORD instance. Looking up a K. It's just a traversal. Why is it O log square n? Look up 1 KNAs. Are you able to short circuit somehow? I don't think so. Your chunk doesn't have ordered keys or anything, right? K and a V. Or are they? Where do the K0 and V0 go in the otherwise case? Can't quite see them. Yeah, they're not here. What the WTF? We insert the A's. But the A's N0 is the map size of M0. Okay, no, I think this is completely screwed, this insert. I mean, unless I'm tripping. Data vector map. And insert. I mean, this can't work, right? Sure, empty the map, transfer the stuff, but you still need to insert a K0 and a V0. You don't, not just the thing in the nursery. Holy moly. So after the default implementation, insert. I mean, hold on, am I missing something here? No, I really don't think I am. Insert KV. Okay, that looks like a really different concept here. This insert is what looks like the merge. But insert 2 KV, KV, fusion insert KV. So that looks correct at first glance. That I think is even earlier. I can't really see anything from here, and swapped out the fully deamortized map as the primary implementation now. Yeah, let's look at this deamortized one and see what insert looks like there. Still not right, it doesn't look like. Okay, I mean, no, if this is really, holy moly, if this is really what's happening here, I mean, no wonder it was fast. Okay, let's imagine, because the threshold is 10, okay? So let's imagine we have a map full of 10 elements. So now n0 map size equal 10. So we're still in the case n0 littler than or equal than threshold. So actually we get to insert one more, an 11th thing. Oh, the note here, it does say excess 0. So, hold on, but you can't, oh no, but then you empty it. So that nursery is not something for the 10 first. I understand. I thought the nursery was for like the very first 10 elements, just to make it fast for like the very small map case. But it's not. It's actually used as a kind of buffer. So if what I'm inserting to actually has the nursery emptied out and tons of stuff into its excess 0, then it will see that the size of the map of the nursery is 0, and it will insert 10 elements into that, and then when it's done, it will use the from list to construct the chunks. Okay. But okay, it will. But what happens? Okay, I still need to look at what happens exactly during the transition, because it looks like it could be losing the current K0 or V0. So if we are at now we have size 11, and we have a 12th member presenting itself in the shape of a key value pair. Now n0 is greater than threshold, so we go to otherwise, and we don't execute this. So we should at least create the map singleton K0 V0 here. I think that would be that would make a lot of sense, I believe. So let's do that. Map singleton K0 V0. Okay, well, so, and then order wise, there's really no sorting that goes on. So so the only thing that you can do with the chunks, that is how, if you're not storing like the max and min of the chunk, then you're not shaving anything. Like you have to look through it, don't you? Let's see. So if I look at k in a chunk of k's and v's, and maybe some other stuff like a current result, so maybe nothing. Oh yeah, because lookup 1 is going to, is it calling itself? It's not. Okay. Well, I think it just passes through R. That's a bit weird. But okay, let's look at the other case. So okay, I didn't know you could use, is that looks like a list comprehension kind of thing. I didn't know you could use list comprehensions in guards. Okay, so what do we do here? We search. What is search? An offset binary search. So that's the trick that Ed talked about to avoid the cache being always overwritten when you're burning a path through the tree. But so it takes a predicate and some bounds, I suppose. Yeah, low high. If low equal high, then you return the value. If the predicate what if predicate m, what is m? Where m is L plus and safe shift HML1 and then safe shift HML6. HML being high minus low. What are these magic numbers? It looks like the middle, but a little bit offset maybe. So you check with the middle. Right, so it's a binary search that just doesn't go exactly right in the middle. So if your predicate doesn't, if the predicate matches, then you know that it's in the first part. Otherwise, you think it's in the second part. But doesn't this require things to be sorted? It looks like this doesn't matter here. Just have a high and low, and your so the high and low are that's the size of the chunk, and the search is taking an I, which I suppose is for the V's in V's. How do I know that it's in V's? I don't know that. In fact, this search is on indices or on K's, therefore, they're on keys. So I is going to be a key, and we check that. We check what? Or we take the key at value I. Oh, okay, this is iterating. Oh, so this int is actually the position in the chunk. It's not the key. Okay, so the position in the chunk, we look at that index and we see whether it's greater than k, which is what we're looking at. That really sounds like it would mean that the thing needs to be sorted. But it's not sorted. Confusion. Okay, but let's say that you get a J, which is basically the index where you found your K, right? No, J is actually the value of K. So you somehow traverse your chunks by bisecting. So this would work if those chunks were sorted. Oh. When they get transferred from the nursery, you do get sorting by default. Map keys is going to give you a sorted list of keys. Map keys, yeah, I'm pretty sure. I see, that's what's going on. Huh. Map. Map and sure, lazy and keys. Let's look at from list and from list with from list n. Oh, there's no from list n here. Maybe because of the version. We use containers. Which version of containers do we use? 0.5 or something. Probably 0.511. And the map. And do we use lazy here? Not sure we do. Maybe using a strict type. Okay. Is from list n actually something that's yeah, that's from the generic. Interesting. Yeah. Huh. Converts the first n element of a list to a vector. Hold on, is that going to... Why do we need to do that? I would think, shouldn't you be? Oh, maybe it's faster. Yeah, must be faster. Keys. And shall we just, yeah, keys. Return all keys in the map in ascending order, subject to this fusion. So there's a piggybacking that's being done on the tree of bounded balance in the containers map. Wow. So interesting. So now our chunks are sorted. Yeah, I'm still a little bit confused about the choice of 10. Sounds a bit weird to me. Like, wouldn't you want to tune that so that it actually is sort of the size of a chunk? Or like a multiple of the size of the chunks? It's a bit weird. Maybe it doesn't matter after a while because the size of the A's becomes really big. So you A's and B's. So you end up inserting 10 elements at a time into something really big. Yeah, I'm pretty sure about this singleton here. Not 100%, but pretty sure. Okay, well, the magic I think is mostly explained then, because then the search is able to properly bisect, and it's actually going to be, yeah, fast. Here, right, it's going to see that the element at J, if the element is at J is K, then you return just V's at J. You found the index, you return for the key, you return the value at the same index. Otherwise, you carry on. Okay, so now I have found that there is order indeed in the chunks. And so so probably that's what the merge needs to do, right? The fusion merge, we need to compare. Is that what? Yes, it needs to compare I and J, and then decide how to merge based on that. Okay, so that makes sense, and so it should mean that this works. But then what? What about those other two constructor for bundle? Well, we've seen in the implementations for instance, plus plus, that not plus 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 here, that we start at nothing, at least for the maybe vector. So that's fine. But however, the chunks seems like they also need to be managed. So the question is, well, the question is, we're going to have to do a step C function that does the same thing for elements as what's done for the chunks. And I think it's okay because those are really just two APIs to traverse the same data structure, but it's not actually constructed. We just construct a function that can yield the data structure, but we really only do some work when we start executing the steps. So okay, so I think basically what we're saying is we ignore this because it seems like that's what the cool people do, and then we put nothing here, and then here we have to build a stream that's going to have a step chunk, and it's probably going to have a merge chunk start. And the fusion, the bundle is yeah, A is a chunk VA. So what? So we have a sort of well, what we have is a stream step CA chunks A and a stream step CB chunks B. And we need to merge chunks start of chunks, well, A0, fine, and chunks B0. Yeah. And so we shall also do some weird indentation things. The chunks, the nothing, the size, and the where. I think the where can be indented like so. Yeah, I think so. Okay, and then step C is going to need to take care of, basically it's going to be pretty much the same logic. Can't we use step there actually? You know what? We might be able, no, we're not going to be able to, I don't think. Yeah, no, we're not. We are not. Let's write this type for step. Step takes a merge state of KA, I don't even know what that A is supposed to be. Oh, yeah, A is actually it's actually A. To what? What looks like step of what step? SA. Okay, yeah. So step of actually merge state blah. Which is not nice, but A. No, KA then, I think. Yeah, that's not a pretty type signature at all, but I kind of need that if I want to guide myself to merge a chunk state, which is going to be a little bit of a beast because now chunks A are not KAs, they're actually chunks KAs. But not even that, the chunks sum V KA. I don't even know what the V is. The V, we're polymorphic in V. Yeah, so actually chunk, not chunks. Is that right? Don't even know. Chunk. Okay, we need to make this a little bit more sane. Really tiny bit. such that this is merged chunk state, and this is, well, this is this, and this is actually what? Ooh. This might be KA actually. No, it is A. Is it this A? Yeah, it is this A. That's actually, weirdly enough, that's where the A's show up, because here they don't. Here, that's just an artifact of the stream creation, this S thing. So indeed the A, well, so yeah, there's an argument that this is actually, that the A here is actually, no, but no, I was going to say a KA, but that's still not right, I don't think. SA, this is the same type as SA here. And so when we have a bundle ID VKA, we don't necessarily know the type of SA is the trouble, right? It's existentially quantified, right? Because of the stream construction. Yeah, we know MNA, but it should work for all S. So when we start leaking, that step actually has an S in it. Maybe that's where I need to, well, that is where I'm trying to figure out. I'm trying to figure out what the step type parameters are, right? Because I'm returning a step. And so we say that that's the S, and then we say that's the A, and the A, yeah, it looks like it has to be a KA. Because we're returning a KA. Ultimately, that's the A, is a KA. The S is this weird beast, and now we're wondering, is A here also a KA? Here we know that in fact it's going to be a chunk of KA. Oh, such ugliness, but it is where it is. So I think that's the step here. And then when we merge chunk start, haven't really figured out where it's incancellative right yet. So we put a match on that, and let's say we have chunk A's and chunk B's. And so what we do with that, we're supposed to apply step CA to CA, and then return case of yield So if we're emitting a chunk right now, we're not emitting a Ka. So this is a chunk, we're yielding a chunk VKA. What's in there? And do we need to pattern match on it? Maybe we don't. Maybe it's just a chunk. Hold on. Maybe we don't need the cancellative addition for chunks. It seems like we would, though. Well, I think we need to understand what cancellative addition is. Okay, well, so that's what we'll do next time. Merge state and cancellative addition. So let's take a note of that. And so we're on our way, I suppose, and on our way to do that we need to understand merge state and cancellative addition to apply it to chunks. All right, so we're actually doing some Haskell finally, and also, you know, touching the innards by trying to update the library to the latest version of vector fusion. So definitely, as I understand, like I've been doing this a little bit mechanically so far. I mean, some things mechanically, but obviously as I zoom in, I start to understand more about the data structure. In fact, you know, to congratulate ourselves from having understood some important things, I think we should check a box or two. Understood that the nursery is used to continuously to feed the Colao 10 elements at a time that are sorted. Oh, by the way, that means actually, hold on, that's still a problem. It's specifically related to this, the size of the chunks actually. If we get larger and larger chunks, then we'll have arrays that are sorted, but only 10 elements at a time. So what's the deal there? Okay. But doesn't this mean that chunks are only sorted 10 elements at a time? Okay, so we have a question, and then hopefully that will help us also understand better what this cancellative addition applied to chunks is going to be. So thanks a lot for watching, and I will see you on Saturday for, let's say, probably our last installment in this 2-week look at the data structure until we rotate with our habitual schedule and go back to, let's see, probably streaming tools, which means going back to GStreamer and automating GStreamer from Haskell next Tuesday. So yeah, feel free to join on Saturday for more cache oblivious data structures and Haskell package archaeology. Thank you so much for watching, and bye-bye.